Hello, welcome to this video about the spatial reference system. So first of all, let's see what is a spatial reference system, that as well a coordinate reference system. That is a coordinate-based system, local, regional or global, used to locate geographical entities. And coordinate systems in the GIS basically are of two different types. The geographic coordinate systems, it's a global or spherical coordinate system based on latitude and longitude coordinates, or we can have as well projected coordinate systems such as, for example, universal transversal Mercator UTM, that provide different ways to project maps of the Earth's spherical surface into a two-dimensional Cartesian coordinate plane. And let's say geographic coordinate system is a global or spherical coordinate system, as I told you before, based on latitude and longitude coordinates. And we see here, for example, that the latitude of the point is the angle between the equatorial plane and the line passes to the point. And in the same way, more or less, the longitude of the point of the Earth is the angle from a reference meridian, in our case mainly Greenwich, to another meridian that passes through that point. You see here the latitude or the longitude of the point. And remember that usually geographic coordinate systems can only be used to measure angles, nor distances, neither areas. And here you have a link where you can browse and have more information about the geographic coordinate system. You see here how it can be represented in GVSig when you upload, when you load a layer, in this case the word, in geographic coordinate system. The coordinate here you will see coordinate in degrees, and the grid composed by meridians and parallels are perfectly squared. And here you have this code EPSG that is usually a coding to name different systems, that in our case in the geographic coordinate system is 4326. Remember this code because you will use very frequently. You see here, if we upload the Middle East, you see that the system is, as I told before, 4326, and the region extends from 34 degrees east of Greenwich until 42 degrees east, always of Greenwich, more or less, and from north to south, from south to north, from 29 degrees north of equator until 37 north of equator. This is just an example to show you how it can be loaded into GVSig, and you see here the coordinates expressed in latitude and longitude in degrees. Here you have, for example, more information in this page, spatialreference.org, that we can find more information about these geographic coordinate systems. We have as well, as I told before, the projected coordinate systems. Like imagine if you put a lamp inside the sphere and then you switch on, you see the images of what is on the sphere projected in the two-dimensional system. So the projected coordinate systems, such as, for example, the most used is the universal transversal Mercator, provides a different way to project maps of the Earth's spherical surface into a two-dimensional Cartesian coordinate plane. And remember that a projected coordinate system is always based on a geographic coordinate system. And unlike the geographic coordinate system, a projected coordinate system can be used to measure distances and areas. And in such a system, locations are identified by XY coordinates on a grid. You see this example of a UTM that is a projected coordinate system which uses two-dimensional Cartesian coordinate system to give locations on the surface of the Earth, and the UTM system divides the Earth into 60 zones. Each of them is wide 6 degrees of longitude. You see the same area, more or less, in this case, expressed in meters. You have X and Y. This is here the EPSG codes, and how you can calculate the EPSG codes. It's the 32, the UTM, you see here 32, 6 or 7 if you are north or south, then the name of the code. You remember each fuse, it's 6 degrees wide of longitude. Here I have information, for example, you can have like Kenya, you are south and north and 36 and 37. So there are different areas, different countries that belongs to more than one different fuse. And here you see how we can represent Africa, for example. This is in the geographic coordinate system, so you have 0 at Greenwich meridian, then you have degrees and 0 at the equator. On the other side, by UTM, you have the different views, each of them is 6 degrees of longitude. As well, when you open web services like Google Earth, for example, the same place, like a Tour Eiffel in Paris, can have two different ways of representing the coordinates. Here on the left, the geographic coordinate system with the coordinates expressed in degrees. Here is the UTM with the coordinates expressed in meters. And here you have as well the number of the views where Paris is located. Well, now it's time to open GVSig and define our GIS working preferences. So next video will be about GVSig setup and preferences. Thanks so much.